Okay, so today we are going to talk about power in circuits, and power is denoted by the letter P. We can think of power as the rate of energy that's either being absorbed or delivered to something. So if we have a circuit that looks like this, where we have a voltage source here, our ground is down here, and then we have some kind of load, the power from the source will be delivered to the load. The load can be a resistor, it can be something like a light bulb, it can be anything that we can model as a load. So the equation for power is equal to the current times the voltage, but from Ohm's law, we know that the voltage is equal to the current times resistance. This allows us to say that power is equal to I times V, which is equal to I squared R, which is also equal to V squared over R. So now we have three equations for power based off of what we know. If we don't know resistance, we can use the first one. If we don't know voltage, we can use the second one. And if we don't know current, we can use the third one. So again, power, the unit for this is the watt, which is denoted by the letter W. So we can look at an example. If we have a 5-volt source, and we have R1 equals 2.5 ohms, and R2 also equals 2.5 ohms. We know that the current going through this circuit will be equal to 1 amp. We can then look at the power for R1, which is equal to I squared times R. So that would be 2.5 watts. Similarly, for the second resistor, again, we would have 1 amp times, or 1 amp squared times 2.5 ohms, which would give us 2.5 watts. Now for the voltage source, which we can just call V, we will have 5 volts, and we know that the current is 1 amp, so we will have 5 watts. So this is all the power components of the circuit. Now we can look at electrical energy. Which is equal to power times time. And the unit for this is joules for energy. We can divide by time and say that power, which has the unit watts, is equal to, we can just denote energy here, over time. So we would have joules per second. So why do we care about power? Well, we're very familiar with resistors by now, and all resistors have a power rating. If you exceed the power rating for it, you kill the component, which many times, if not all the time, your resistor will fail open. Now with resistors, our electrical energy is completely turned into heat, and the rate at which the heat is dissipated is our power. So we can have a resistor right here, and we have our voltage source right there. Now we can expand the camera a little bit. And let's try to get everything in view. So we can start applying a voltage to the resistor. We can see as the voltage goes up, the current goes up. Right now, we'll do a little experiment. We have a piece of paper, and we will just touch that to the resistor, and it's not hot. Well, it's a little bit warm, but it's not too hot yet. So now we can turn the voltage up a lot. See, as we start smoking, we're killing the resistor right now. So we will turn this off. Got a little bit of fire there, which is pretty cool. But that's what happens when you over voltage or put too much current through a resistor.